Our 10.1 area of triangles, parallelograms, and trapezoids, we're going to find the area of these figures. So area, this is basically the space inside a figure, or the space a shape takes up. And we measure that in square units. What do I mean by square units? If we have a square that's 1 by 1, then this is 1 square unit. Okay, this area in here is 1 square unit. Okay, the base of a parallelogram, this is really just any of the sides, but usually we just refer to it whatever's on the bottom. Okay, and the altitude, this is the segment that is perpendicular to the base from a vertex. So here you'll see that it's perpendicular to this base down here. We could add in a little right angle symbol. So the H, we also call it the height, it's the same thing as the altitude. So you might want to write height here. Those are interchangeable words. Is always perpendicular to the base, and it goes through one of the vertex, meaning it goes through the top corner here. So the area formula for a triangle is 1/2 base times height, or you could write it as base times height divided by 2. And in this picture, the picture is actually wrong, so let me just fix this real quick. This picture should be multiplied, so it should be base times height divided by 2. Now I want to show you where that comes from real quick. That comes from the fact that we could make any triangle into a rectangle. If we made it into a rectangle, what would happen is that this triangle area would be exactly half of this triangle area, and this triangle area would be exactly the same as this triangle area, right? So it represents, this area here represents half of this whole rectangle, and this area here represents half of this whole rectangle. In fact, this whole rectangle would still have a height of h. It would be base times height for the whole rectangle, right? So this triangle would be half of it. That's why we just divide by 2. Alright, so let's put this to use. Example 1, find the area of the triangle. Again, the formula is just 1/2 base times height. Let's plug it in. We got 1/2. The base here is the bottom, so 1/2 of 15 times the height of 4. Now for me, whenever I see a 1/2, I like to multiply by the even number first, because that's just a little bit easier to do. So 1/2 of 4 is 2, and 2 times 15 is 30. So the area is 30, and since our units are in inches, our area units are in inches squared. Alright, so that's kind of all there is to it. So I want you to try practice number 1A on your own. Again, the formula is 1/2 base times height, or you could do base times height divided by 2. It's up to you. Go ahead and give it a shot and then check back for your answers. Okay, so I just plugged the values in the formula. Area equals 1/2, the base is 5, the height is 8, so I did 1/2 of 8 first, so that's 4. 4 times 5 is 20. And again, the units are inches, so it's inches squared. Alright, let's talk about example number 2 now. So in this one they say, given the area and the base, find the length of the missing height. So first let's just write the formula. The formula we know is the area equals 1/2 the base times the height. Okay, well, we know now that the area is 18 feet squared, so we could just plug that in. 1/2, the base is 3 feet, and the height, that's what we don't know, so let's just leave that as h. And now basically we're just going to solve for h. So first thing I would do is I would just get rid of this 1/2 and multiply both sides by 2. When you do that, you're going to get 36 square feet equals 3 feet times the height. Now just divide both sides by 3 feet. 3 feet, that means that 1 unit of feet is going to cancel out. 36 divided by 3 is 12. This cancels out here, so you're left with the height equals simply 36 divided by 3 again is 12 feet. And there we have kind of used the same formula for area, but worked backwards to find the height. Alright, example number 3 says, find the area of the quadrilateral XYZ if XZ is 39, HW is 20, and YG is 21. So let's just kind of plug those values in. So again, they want the area of this whole figure, but we only know certain parts. So let's plug in what we know. We know that XZ is 39. So this distance here is 39. We know that HW here is 20, and that YG here is 21. So the trick here is to actually break this into two triangles. Right? We could do the top triangle and the bottom triangle and then add those two areas together. So triangle 1, the one that I did in red, is going to equal 1/2 the base. Well, the base is this distance along here, so it's 39 times the height, and the height is this distance here, it's 21. And then the bottom triangle, we'll call it triangle 2, that also equals 1/2. The base is still 39, but now the height there is 20. And so we're just going to work these both out. I'd recommend just using a calculator for this one, because it's going to give you a decimal answer anyway. So this first one is 409.5, and the bottom one is 390. Again, we're just adding them up. So if you plug that in your calculator, 409.5 plus 390, that is 799.5. So that's the area of the two figures together, which means that's the area of the whole shape. All right, let's go to the next page. All right, so that was triangles. Let's talk about parallelograms. The area formula for a parallelogram is simple. It's the same as a rectangle, but I'm going to show you why. So the area for a parallelogram is simply the base times the height. No divided by 2, no multiplied by anything, that's it. Here's why. Remember that a triangle is base times height divided by 2, or 1/2 base times height. Well, in every single parallelogram that will ever exist, you can always chop it into two triangles that are congruent. We could go through how we prove that they're congruent real quick. We know that these two sides are congruent. We know that opposite sides are congruent. And look, those two triangles are congruent by side, side, side. Therefore, they have the same area. So really what you're doing when you're finding a parallelogram is you're finding the area of two triangles. Well, that's 1/2 base times height plus 1/2 base times height. Sorry, my handwriting sucks there. Well, 1/2 plus 1/2 is just one whole. And so the area is just base times height. That's it. So let's put that into practice here. Let's go to example number 4. Find the area of the parallelograms. Literally all we're doing is multiplying here, guys. It's really that easy. So area equals base times height. Base is 12. 12 times 5 is 60. So the answer here is 60 centimeters, but now we're talking about area, so it's squared. That's it. I know, real tough, right? Okay, so I want you to go ahead and try practice 4A, give it a shot. And then also I want you to try practice 4B. We did a problem like this on the last page, where I give you the area and you find the missing length. So go ahead and give both of those a shot, pause the video, and then put your answers in. And then unpause it when you're ready to check. Alright, so practice 4A, easy. Area is base times height. The base is 7, the height is 10. 7 times 10 is 70. So 70 inches, or 70 square inches, because we're dealing with area. The next one's a little bit trickier. We know the area is 24. We know that the base is 4, but we don't know the height. So we have to solve for the height. So we divide both sides by 4. 24 divided by 4 is 6. So the height must be 6 centimeters. If we put the units in there like I did on the last page, you'd see that centimeters squared divided by centimeters just gives you centimeters. That's where that came from. Or you can just look at the problem and say, hey, this has to be in centimeters and this has to be in centimeters in order for this to be centimeters squared. All there is to it. All right, let's talk about example number 5. This one's fun. This one says find the perimeter and the area of the figure. So let's talk about perimeter first. I think that's going to be the easiest one. So perimeter is just all the sides added up. Well, if it's a parallelogram, opposite sides are congruent. So this is 18 and this is 12. Awesome. So all we have to do is add up all the sides. Well, 12 plus 18 is 30. And so we have another 30 over here, so it's 60. That part's easy. Now let's talk about the area. Because remember, area equals base times height, where the height is perpendicular to the base. So, this is a common mistake. A lot of people don't see a number here. They see a number here and they just go, oh, it's 18 times 12. But 12 is not a height. The height is here. And we do not know the height, but we can find it. Let's zoom in. If you think back to chapter 8, we learned something about special right triangles. We have a right triangle, 60 degrees, therefore this has to be 30. So this is a 30, 60, 90. And so we can use our properties of 30, 60, 90s to find the short leg, and then that'll help us find the long leg, which is our height. So one of the things we learned was you could take the hypotenuse and divide it by 2 to get the short leg. So this distance here is 6 inches. Then we learned to go from the short leg to the long leg, we just multiply it by rad 3. So this distance is 6 rad 3 inches. Okay, we now have the height, so we can find the area because the base is still 18, but the height is 6 rad 3. So here's the deal. We can leave this in exact form, and that's how I want it. So all I'm going to do is multiply the 18 and the 6. I can do that in my calculator. That's 108. So I'm going to leave this as 108 rad 3, and remember my units are inches squared now. And I can leave my answer just like that. If they ask for a decimal and round it, I can plug that in my calculator and get a decimal. But until they do, I leave it in exact form. All right. Let's go on to practice number 5. Very similar problem. Very, very similar. So I want you to think about how you can draw a triangle in there, how you could draw a triangle in here, or maybe in here. And maybe it'll be a 30, 60, 90. Check the angles to verify, but I think that you might be able to find one and solve for both the perimeter and the area. Go ahead and give it a try, and then check back when you're ready. Okay, once again, the perimeter is easy. Opposite sides, 6 and 6, 15 and 15, so 6 plus 15 is 21. And then this is 15 plus 6 is also 21. Add those together, you get 42 units, whatever that is. We don't know what the units are, but we know there's 42 units around this. Okay. Again, I wanted you to draw a line in here to see the right triangle, just like the last problem. But for this one, you had to kind of draw it in. If we draw straight down, then this angle is 90. Since we know this whole angle is 120, 120 minus 90 leaves us with 30. And this would also be 90 because we went straight down. So 30, 90, this has to be 60. So we have the same type of triangle. So 6 divided by 2 is 3. 3 times rad 3 is 3 rad 3. So now I have the base and I have the height, so I can find the area. 15 times 3 is 45. There we go. We are done. Let's go to the next problem. All right, let's talk about example number 6. The Bushers are planning to recarpet the first floor of their house now that they have a new baby. Find the amount of carpeting needed to cover the living room, den, and the hall. So let's talk about that. That is just this area, and this area. So we're going to add up those 3 areas. They're all just parallelograms. They're actually all rectangles, so they're even easier. And so we have to solve for a couple of parts. The den, that one should be easy. I'm just going to write D for den. That's just 9 times 15. And 9 times 15 is 135. So we got that. Let's try the hall next. The hall's a little bit trickier because we don't know this distance. However, we do know that 15 plus 15 is 30, and this total distance should be the same as this total distance, and this total distance is 30 plus 5. So it's 35, and I have 30 here. So that means that this distance here has to be 5 feet. We also can see that the hall is the same height, we could call it a height, as this room, the living room, so it's 13. So the hall is 5 by 13, which is 65. Oh, and I should put in my units. This would be square feet. This would also be square feet. And now let's do the living room, L. That one's pretty straightforward because it's 15 by 13. I'm going to do that in my calculator real quick, and I get 195 square feet. All we got to do is add these up now to get the total area, the total amount of carpet we need. This will save us some money so we don't have to overbuy. 395, so we got 395 square feet. Boom. And we're done. Let's go on to talk about trapezoids now. Alright, so here's the deal with trapezoids. Trapezoids, just like parallelograms, are really just the area of two triangles put together. The only thing here is they're not the same triangle. They're not congruent. But they both have the same height. See this height here? That's the height of this triangle, and it's also the height of this triangle. So they have the same height. So we can add one triangle, base 1 times the height divided by 2, base 2 times the height divided by 2. Or maybe another way of thinking of this is triangle 1 plus triangle 2, we could say, isn't that 1/2 base 1 times the height? And triangle 2 is 1/2 base 2 times the height. And we could add those things together. Well, what they want you to see that you can do here is pretty much what they did here, is that you could factor out things that are in both. You could factor out a 1/2, so let's bring that out front. And you could factor out a height, because that's in both. It's the same height in both. When we do that, all that's left is base 1 plus base 2. And so that's the area formula for a trapezoid. So let's go ahead and write that in the box here. Area of a trapezoid is, we usually just write it as height divided by 2 times base 1 plus base 2. You could also just write it kind of how I have here, 1/2 of height times base 1 plus base 2. Either one works. Okay, now let's talk about how we can use this thing. Find the area of a trapezoid TVWZ with the vertices T, -3, 4, V, W, and Z. Let's plot these real quick. I'm going to pause the video and just plot them quickly. You could probably do the same. So go ahead and plot these. Okay, so I plotted the points. Now I can connect these dots here. And we can see we have a trapezoid. And they want us to find the area of this trapezoid. Well, we know that the area of a trapezoid is the height divided by 2 times base 1 plus base 2. So we can actually figure all this out. For example, we could figure out the height. That's this distance up and down. Now, since we put it on a graph, we could just count. That sure makes it easy. We could just go 1, 2, 3, 4, 5. So the height's 5. Now, the other thing we could do here is, if we look at the y value here is 4, and we look at the y value down here, it's -1. So we could also find the height by doing 4 minus a -1, which I'll just do right here for you. The height also equals 4 minus -1. Well, that's a double negative, so it turns into a plus, which turns into 5. And hey, that's the same thing we got just from counting. So it doesn't really matter how you do it. It's kind of why I like graph paper. It lets you just count. So let's plug that in. Area equals, the height is 5. Now let's find the bases. Well, base 1 is usually what we refer to as the top. Well, once again, we could just count. 1, 2, 3, 4, 5, 6. Or we could say it's 4 minus, 3, that's the x value, 3 minus -3, 3 minus -3 is 6. So this distance is also 6. Now let's do the bottom one. Again, we can just count. Now this one's getting kind of long, so maybe counting's not that great of an idea. So I'm going to look and see that I'm going from -5 to +6. So I'm just going to say, for base 2 here, I'm going to go 6 minus -5. As long as you always do the bigger number minus the smaller number, so that means the positive minus the negative, this will work just fine. So 6 double negative turns into a plus, so 6 plus 5 is 11. Now, if I wanted to, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boom. And we have our two bases. Now we just got to simplify it out. 6 plus 11 is 17. So area equals 5/2 times 17. And from here, I would just go ahead and go to the calculator because it's going to be a decimal anyway. It's going to be, there's a couple ways you could write it. You could write it as 85 halves or 42.5. Again, this is just units squared, so a lot of times I just put a U there for units. And we're good. We found the area of the trapezoid on the graph. Pretty easy. Just got to use the formula. Okay, I want you to try practice number 4 on your own. This one, they tell you a little bit about the trapezoid. It has an area of 250 square inches. They want you to find the height of PQRF if one base is 20 and the other is 30. Hint, use the formula for area. I'm going to write that up on top one more time. Area equals height divided by 2, base 1 plus base 2. So give it a try. All you got to do is plug in the information and solve for height. Okay, so all I did is plug in the area and plugged in my 2 bases. I know that when I'm multiplying it goes on top, so 20 plus 30 is 50, and I just went ahead and put it on top. 50 divided by 2 is 25, so I realize I have 250 equals 25H. Divide both sides by 25. 250 divided by 25 is 10. And then I knew it was in inches because everything was in inches, right? The area was in square inches, and these are both inches, so actually they didn't specify, but we could just assume. So that's it. The height must be 10 inches, and we're done. All right, guys. Remember, I want a summary from you and a question. Explain in complete sentences how the area formula for parallelograms and trapezoids are related to the area formulas for triangles. And we did go over those in the notes. See you guys on the next video.